Well, for today's question, you get to see some of my lovely artwork in which I've drawn possibly the world's ugliest scarf. So I'm using that to start us thinking down a slightly different avenue. Stepping away from the data structure question for a moment, if you were knitting a scarf, so you're knitting together thread, yarn, I suppose, and you're creating a scarf with stripes of different colors like this one. Think about which colors would be easy to remove and which ones would be hard to remove. Your friend asks you, they say, "Oh, I love the scarf you're knitting for me, but I would like you to swap out blank color for something else." Which of these colors would you resent them more for asking you now to swap it out? Versus which ones would you say, "Oh yeah, that's easy. I'll get right to that. It'll only take a few minutes." And similarly, where would it be easy to add on a new color? And where would it be the hardest to add a new color to the pattern? So pause for a moment and think about these questions, dealing with this scarf idea where it's kind of growing as we knit on more. Where would it be easy to add things? Where would it be easy to remove things? And why? What about it makes it that way? Pause and think about it. Okay, so I would think that if we were to consider what's easy in terms of pulling thread and sort of removing a color or adding on thread and adding a color, that the easy places to add or remove are at the sort of pink ends over here, either end of it where the fringes are. So the pink sections are easy to remove, or they're easy to add something else onto. So either end of it is easy. And the places that it's hard to make changes are in the middle there, right? Like if someone asks you to swap out the black, you have to unravel the entire thing to get to that section. So any of the middle sections are hard to get to, they're hard to remove, they're hard to add from, etc., or add to, remove from it, etc. Any of the middle sections are very hard, the black being the hardest. Because you would have to remove all the way through from one direction or from the other. So if we step back into our data structure territory here, and we think about some of the terms that we were learning and some of the ideas that we were talking about recently, we could think about this as the head and the tail of a list that we're working with. So we could try for a design in which the head and the tail are easy to access and they're easy to make changes there, much like this design for the scarf, where it's easy to get at the head or get at the tail, and it's even easy to remove the tail or remove the head, or to put new things on the other side of the head here and sort of functionally make a new head onto my scarf list here, or a new tail onto my scarf list here. One way that you'll see this done in the activities today is to think about an array where you leave some empty space on both sides. One of the neat things and why it was easy to add stuff at the end of an array, the tail of an array, the sort of default array, is because it's got empty space there often. And so one way you might achieve this is to try to leave some empty space before the first real data and some empty space after the first real data. So this is one option that you could look at, as sort of a floating array that's toward the middle and leave some empty space. And it will have its ups and downs, just like any implementation of a list will have its own ups and downs. Another that will break us away from that model is to think about this idea of a node. So if my colors are the data, there's sort of a space occupied by that color, and it's connected to the next segment, the next space. And we can create objects like nodes, where we create some class that's a node, and it has some data that it stores. So it will have its own data. Actually, I'm going to write this way. So if I imagine a node in space, it is a node. It stores some data, and it has a way to indicate where you'll find the next data, or in other words, the next node. And so this is another concept that we'll start to consider is, what if I had some way to indicate that the next node lived somewhere else, and then I'd be able to find that node and its different data that would presumably be different than the data of the one that I'm currently looking at. And I could continue to do this where I continue to indicate where to find the next data and the next data and so on. And so this is another idea, and it breaks us away from the concept of a list, where these are boxes of stuff that have to be stored exactly as that one item, only the data goes there, and they have to be stored exactly next to each other. They have to be stored as a chunk in memory to get that fast array behavior. Well, what if we broke away from that concept of the chunk altogether, and we had some individual unit, a node, that stored one piece of data, and it just tells us where to look for the next stuff, and the next, and the next. And so could we use that idea to try to be able to flow from one item to the next and the next in a way that doesn't lock us into a fixed size or a fixed sort of fitting things in the middle of each other and shoving everything over and stuff like that? And so we'll see some benefits and some costs that come about if we even fully break away from that array model of everything living all in one unified chunk. And we get some whole new ways to look at these concepts. And you'll explore both of those ideas as you look at parts C and D from the activity today.